warahmatullahi wabarakatuh. Welcome back, my friends, to my YouTube channel, Drilling and Workover. This is Abdulaziz Gabr. I am accredited instructor in IWCF Well Control and IEDC Well Sharp. Also, I am accredited instructor in IEDC Mod Engineering for Basic and Advanced Mod School. We will continue today, inshallah, about very important high performance mod, which is used in the reservoir section in order to the in order to avoid any damage that could happen to the reservoir. Today, inshallah, we will talk about something is known as reservoir drill in fluids. Actually, if we try to drill any well, okay, why we drill the well? In order finally to get the production of oil. Okay, so if we have drilled the well and finally we damaged the reservoir, we will actually the result we will not get good results, and we will damage the reservoir, and we will lose a lot of money. So we have to make a special fluid to be used in the reservoir section with special characterization or special properties in order to reduce the damage inside the reservoir. Okay, inside the reservoir. Actually, as we have taken in the functions of the functions of the drilling fluid, one of the functions is to reduce the filtrate. Why to reduce the filtrate? Because if you see that the filtrate could make a flush to the near wellbore zone, and makes skin, and makes damage into the reservoir, which leads to reducing the pore size or the pore throat, and leads to very drastic or catastrophic problems to the reservoir, and it needs more money to make stimulation for the reservoir. So what is the reservoir drill in fluid, or its abbreviation RDF? Actually, it's a normal fluid. It is the same fluid like the conventional one, but it has some special properties, which is to reduce or make non-damaging characteristics to both the formation and to the completion assembly as well. Okay, uh, and also to maximize the productivity is the key objective in the design of the optimum reservoir drilling fluids. So here, what are the drilling issues that we have to take care while drilling the reservoir sections? Good drilling properties like the hole cleaning, especially in the horizontal well. What are the hole cleaning methods that we use in making hole cleaning for the horizontal section? And why we are talking about the hole cleaning? Because as you know, in the horizontal section, the cuttings are in the low side, so that once you start to make production to the well, these solids will make plugging to the screens, and leads to a great problem, and it may lead to a pull out fall with the screen assembly, and at this you will lose a lot of money. So the cost is very important here. Number two, the lubricity. Okay. Number three, the low fluid loss. The low fluid loss, especially the bridging and the fluid loss additives to be added in the reservoir zones. Actually, the low fluid loss here is very important because, as I told you, the filtrate may make flush to the near wellbore zone, and it leads to high skin factor or positive skin factor, and it is very big problem. The bridging, so that we use here some materials. These materials must be non-damaging. For example, the back or the polyanionic cellulose, it is not used in the reservoir because it's cellulose. Cellulose is a damaging material. It cannot be acid soluble. Okay, so we don't use, for example, the back or CMC or anything that makes damage to the reservoir, but instead we makes very important technique. It's called the PSD, or particle size distribution. It depends on using a blend of bridging material in order to help us to reduce the filtrate. Okay, so we are adding here very important bridging materials, and they must be acid soluble. For example, like the marble, the calcium carbonates, the baracarb, or something like this. So this is very important. And in addition, we add some fluid loss additives, which are very important, and it has to be non-damaging to the reservoir. Number three, the formation inhibition. Actually, the shear inhibition is very important. And as I told you in the formulation of the mud, we use shear inhibitors. There are two types of shear inhibitors. Number one, in the shear inhibitors are the uh, asphaltic material, okay, like the Saltex, gelzonite, BXRL, all these chemicals are asphaltic material. And the other types are polyamine. So we use the polyamine in the reservoir zone, like Calastop or Calagard or some other chemicals. So take care of this very important note. The fluid compatibility with the reservoir fluids. The fluids that we are using, okay, must be, or the brine we are using must be compatible with the reservoir in order not to make scales or make damaging to the reservoir and forming some skin or making skin factor to be very high, especially in the near wellbore zone. Finally, in the drilling issues, we have to take about the environmental restrictions to be taken into your account. Okay, and finally, and the most important parameter in all the oil field is the cost. What you pay, and when your money comes, or what is known as the flow of the cash flow money. Okay. So the reservoir drilling fluid selections depends on number one, the formation inhibition, number two, the clean up design, and I told you that the clean up design is very important due to the screens, especially in the open hole completion. Environmental considerations must be taken into account. Completion design, fluid compatibility to the reservoir, well objectives, and density and bottom hole requirements, and finally the cost and the availability must be taken into account. Okay, the most famous type of the RDF, or reservoir drilling fluids, are the what's known as Pro series. Pro series are very important types in drilling the reservoir. The Pro series in the reservoir drilling fluid, for example, the Flow Pro NT, okay, all these are systems, but they are the same like the conventional one. But as I told you, they don't have damaging material. Okay, so each company makes a system for itself and call it with a commercial name in order to make more money and to get more revenue. So the first type is called Flow Pro NT, which is water-based reservoir drill-in fluid. Flow Pro SF, okay, it's solid free water-based reservoir drill-in fluid. Dipro, which is high density water-based reservoir drill-in fluid. Versapro, which is oil-based reservoir drill-in fluid. NovaPro, which is synthetic oil-based reservoir drill-in fluid. FuzzyPro, and which is reversible oil-based reservoir drill-in fluid. And a comprehensive range of the fluids to meet exacting reservoir and environmental consideration. So all these types, or all these systems, are used to drill the reservoir section. So you can use any one of them according to the situation and according to the parameters or the considerations that we have talked in the last slide. Okay. Okay, what is the applications of the Flow Pro NT system? Okay, it's used in the horizontal drill in fluid, vertical drill in fluid also, on the side tracks also it is used, and in gas injection wells. Also, it is used in the multilateral. So all of these are in the reservoir sections. Okay, it can be used also in the cold tube, in the aerated fluids, in the milling, and in coring too, and also in water injection. What are the components of the Flow Pro NT? As it is usual system, it is like all the system: base fluid, fluid loss reducer, viscosifier, some bridging material, some inhibitors, and weighting agent, okay, or weighting material. So these are the components. But take care that these components must not be damaging to the reservoir or and must be acid soluble. Okay. Number one is the base brine. Okay. Number two, viscosifier, fluid loss additives, and bridging agents, pH control, inhibition, lubricant, and breaker system uh, in order to damage the filter cake after finishing the job. Okay, so this is very important. The base brine. What are the brines that we use in the Flow Pro system? Actually, the Flow Pro system, like it is the same like the solid free or low solid non-dispersed mud. It is the same like it. Okay, so there is no solids or very little solids in the mud. Okay, so the first one or the base fluid is called here the base brines. What are the base brines? Can be fresh water, can be filled brine, it can be potassium chloride, it can be calcium chloride, it can be sodium chloride, and it can be sodium bromide. Also, other brines may be calcium bromide mud, zinc bromide mud, potassium formate, sodium formate, and cesium formate. But actually, the most important thing in these brines that they are compatible with the reservoir fluids. Okay, so take care of this very important note. Number two, the viscosifiers. What are the viscosifiers to get the rheology and viscosity, yield point, gel strength, all the parameters that helps me in the hole cleaning while drilling with this system. So what are the viscosifiers for the FlowPro NT? Number one, a chemical is called FlowVis NT, which is non-clarified and non-dispersed, as I told you, non-dispersed premium grade of Dansan gum. Uh, okay, it provides low shear yield point. Why it provides low shear yield point? Because as I told you during making the hole cleaning in the horizontal section, it's very important that the reading of the 6 RPM and 3 RPM must be minimum equal to the hole size, and so that the polymer must give some parameters to the low shear yield point. Number two, in the chemicals that are used or that may be used in the FlowPro NT viscosifiers is called BioVis. The BioVis it provides also low shear yield point, and it is used in bin hole upon production. Number three in the components for the FlowPro NT fluid loss additives. Uh, Number one is called Floetrol, and I have already worked with this chemical or this polymer Floetrol. It's very important polymer. It can be used with high calcium environment, can be also used in high thermal with high thermal stability. So the Floetrol is very good chemical. It's hydroxypropyl cross-linked starch. It's stable up to 250 Fahrenheit. As I told you, its thermal stability is very high. Other type is called dual flow. It's hydroxypropyl cross-linked CM or carboxymethyl starch, and it is also stable up to 250 Fahrenheit. The bridging agents. The bridging agents that are used in the reservoir zone. As I told you, they must be acid soluble. They must be acid soluble, like the baracarb, like the marble, the calcium carbonates, all these chemicals that are be used. And before we are making the bridging material, we have to make some things called particle size distribution, and then we check for the filtrate with and the spark loss and the total spark by using something is called BBT test, which is the permeability plugging tester. Okay, this is very important too. So we use, as I told you, safe carb or baracarbonates, okay, which means carbonates, and it is used. It's ground marble, high purity, minimum 98 acid soluble. Okay, as I told you. For example, the safe carb 2, its size is 2, safe carb 10, and another one is safe carb 20. It's used OptiBridge. Okay, OptiBridge is a program. It's used to make the BSD or particle size distribution to select the safe carb blend or safe carb mixture of those sizes with different sizes in order to get the optimum particle size distribution. As you see here, this is the filter cake. As you see from the filter cake, you see that there is here the bridging material, okay, and they are covered with plastering effect from the uh, fluid loss additives, like for example, as I told you, Floetrol or other chemicals. So this is very important to make the BSD to make a strong what's known strong filter cake while drilling the reservoir zone. Why we make this? Because of the high overbalance that we are drilling for the reservoir zone to avoid any well control issue. Okay. The invasion control, as you see, as I told you here, the invasion control, we will talk about it in details in very important lesson. It's called stress gauge technique and the particle size distribution. Why we use this? Because these are used especially in the reservoir zone. As you see here, for example, while drilling without are some solids uh, are making the filter cake here, okay, and all the filtrate is coming to the formation. This makes a lot of problem. So we use some chemicals or some bridging material to help us to control this filtrate, okay, by making the particle size distribution. We are using from blend, okay, or mixture from different sizes, and these sizes makes a very good filter cake, as you will see inshallah in the next lecture. Here, as you see here, for example, if we assumed that the all of the bridging material of the same size, as big as you can so as big like this, okay, so that at this time you will see a lot of vags between the large particles, and so that it will let the filtrate to be very high. But if we make blend or mixing between the large particles, the medium particles, and the very fine particles, we will make very strong filter cake. And I will discuss with you the mechanism of formation of this type of filter cake in the next lesson, inshallah. Okay, and as you see here, it is the same meaning. If we are using the same size, it will not make good filtration. Okay, it will not make good filter loss, and a lot of filtrate will pass through them. But for example, if we use different sizes, as you see, this is big, this is little, this is low, and this is lower, and this is the least, and this is very fine. If we are making mixing of them, okay, and use the OptiBridge system, or what is known as particle size distribution system, in order to get, for example, which how many of the big, how many of the little one, how many of the very small one, and how many bounds of the very fine one. So if we get the best formula for all this, we can make very good bridging, and it help in reducing the filtrate, okay, by what is known as particle size distribution. Okay, and this is a program that can be used for this. Okay, the FlowPro other additives. What are the other additives? We can use pH control like MgO or NaOH or KOH, shear inhibition, and as I told you, we are using the Kala stop or Kala guard, for example, because these are very important and they are polyamine, not asphaltic material. Lubricants can be used, for example, Radia Green or Fina Green is the most important one. Non-emulsifiers like safe breakers or some are used. Biocides, because these are bacterial places due to the deeper zones, and this is very important. The biocides like safe side or another chemicals. Breaker selection depends on the acids like the microwash job, oxidizers, enzymes, and the mud solvent. Okay. Now we will make open hole completion. So after pull out of hole with the cleaning assembly, okay, with the cleaning assembly or slick assembly, we will run in hole with the completion. Okay, we run in hole with the completion. It is screens. Okay, because it is open hole completion. We are running with screens, wire wrapped screen. So that before pull out of hole, okay, we have to be sure 100% that the solid percent in the mud is very little, in order not to make plugging to these screens. So how we make sure that the solids are very little, and the bridging material and the other stuff can are we have already get rid of them. Okay, how we know this? Actually, there is something called clean up design. There is no clean up design for it. If the completion design utilizes the gravel bag, for example, the grade of safe carb calcium carbonates must be designed to be produced back through the screens. Okay, they must be designed to be produced back through the screens, and doesn't impede production, or doesn't make plugging to the or throat or to the screen. Okay, so until now, we need to know the test to check for them. What is the test? It's called Production Screen Tester, or BST. What is the BST? It's very important test and very simple test. As you see, this is the cell of the test, and this is a bottle with 100 psi. Okay, we are sorry making with this regulator for this CO2 cartridge to increase the pressure here to be 100 psi, and we check for this cup to fill this cup in 1 minute. This cup must be filled as soon as possible and as quick as you can in less than 1 minute. Otherwise, we will continue circulation. We may circulate for 6 hours, 7 hours, 8 hours, and sometimes, in order to get rid of the solids. And to get rid of the solids, we have to make the screens to be very fine. We have to use the solid control like the centrifuge, the other types, in order to make the solids, to get rid of all the solids in the mud, and the mud is very fine at this type. So how we know this? By this test. It's called production screen or BST. It's manufactured in stainless steel, as you see. Many parts standard for Ofit with fittings. Or Ofit is the main company to provide this equipment. Cell capacity is 1200, okay, millimeters. Its weight is 10.5 kilograms, and maximum pressure is 100 psi, and it is quick and simple to be used. Okay, uh, we use any of these screens according to the size of screens that will be run in whole. So according to the size, if it is very fine, for example, we'll use this type. If it is not very fine, we will use this, and other one is when it is coarse, we will use this type. Okay, so we use these in the test according. This is called screen inserts. In the test, it is according to the screens that will be used in the open hole. So it is manufactured from section of the field screen. Most types of compression script applicable. Wire wrap, for example, pre-pack, excluder, and strata pack. All these types are used as I told you. Okay. How to mix this system? It is the same like any water-based mud system. We are making first of all the base fluid, then we adding the makeup water, for example, caustic soda or caustic potash and soda ash. Okay, then we add the fluid loss reducer, then we add the viscosifier, and finally we add the inhibition and the salt, and finally we add the uh, wetting agent, which must be, as I told you, acid soluble. Okay, so what are the mixing? Mix the phosphors and fluid reducer in fresh water to get the maximum, with the maximum shear to get the maximum properties of them. Then add the salt, then mix the caustic soda and soda ash, add the bridging agent, add lubricant if required, and add the Calaguard or polyamine shale inhibitor if required, and finally add run a check, okay, and adjust if necessary. Okay, what are the properties of the flow pro nt? As you see, the density with or without calcium carbonates. Okay, we use mainly the calcium carbonates. The drill in fluid density is brine plus additives. Why we are using here the brine, especially the salt saturated one? Because we are taking the maximum weight of the salt, then we are adding the carbonates, for example, in order to reduce the solids as much as we can in the mud. Okay, we can increase the density another ppg by using the calcium carbonate, and calcium carbonate is acid soluble. Acid soluble, this is very important. Solid free version relies only on brine for its density. Okay, what are the rheology of the Flowpro NT properties? This is very important. There is inverted the plastic viscosity by the yield point is 13 plastic viscosity, and yield point is very high, as you see is 40. Gel starts flat and spreads with solids. Okay, but the gel must be flat. Why flat? Because if it is progressive, it will make a great problem, and you can't run the screens, or the screens may be plugged while running. Rheology really based on the low shear values or low shear yield point values, because most of the FlowPro NT is used in the horizontal section in the reservoir. Thank you very much today for the first lesson in the drill in fluids. I hope, inshallah, I have give you good lesson about the drill in fluids, and I hope to see you later, inshallah. Thank you very much, and see you later, inshallah, and goodbye.